Greetings and welcome, friends. Yesterday we were talking about a brand new parent function called an absolute value function, which oddly enough happened to have an absolute value in it. So it'd be something like this: f of x equals abs x is sometimes what I call that. And abs x had a couple interesting features. The parent function has a vertex at the origin. And the right side of it has a slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1, etc. And the left side had a slope of what? Negative 1. And so I could do that by going down 1 over 1. But since I'm starting here, I'm going to go up 1, backwards 1, up 1, backwards 1, up 1, backwards 1. And so I end up getting a nice V-shaped graph from this absolute value function. And one of the ways I like to think about this left side of it is that these points are all the ones that would have been they would have been negative values down here, but they got reflected up to positive values because someone yesterday had summarized absolute value as being a taking any number and making it non-negative or positive, right? Except for 0. 0 stays as 0. 0 is neither positive or negative. So here's the parent graph, and then we graphed these using transformations. And so this looks like it's going to be some sort of a translation. And is this going to be vertical or horizontal? Let's see. It's on the outside, and I agree. It is going to be vertical. Well done, well done. And it's going to shift down 4, right? So all of these points, I'm going to just take the vertex. The vertex is now going to be at 0, negative 4. This point at 1 high is now negative 3 high. This point at 2 high is now negative 2 high. This point at 3 is now at negative 1, etc. And I can plot those points, right? Everything's been shifted down 4 units, right? Down 4 units. And does that change the steepness of my graph? Nah, it doesn't deform that in any way. It's the same shape. It's just changed where it's living. That's all. That's all that's happening. And so yeah, translations don't change the shape of it. Just changes where it is. So that's what that would look like. The new vertex is there. Oh yeah, another piece of information about absolute value graphs we learned was that they are symmetric, meaning they are mirror images of themselves over, before they're translated horizontally, over the y-axis, right? So notice these points over here are all mirror images of that side and vice versa. Let's see, they also asked us to describe domain and range. Well, domain, there we go. So the domain would be, if I took this purple graph and smushed all of its values to the x-axis, I just crushed it, right? What x values would it exist for? What would it cover on that x-axis? Right, I think it would cover everything, right? The whole x-axis would be covered in the goop of that purple graph if I smushed it. And so the way we would describe that is all real numbers. The domain is all real numbers, right? It covers everything. Another way you can write that, by the way, is you can say it goes from negative infinity to positive infinity, but not including those values, because infinity and negative infinity are not actual numbers. They're more concepts. How about the range? If I was to smush this to the y-axis here, and these ones over there, this one's here, this one's here. What would be covered for the y-axis? All of these points up here would be covered all the way to here, right? Do you guys agree? Yeah. So the range, I could say, is the set of all y such that y is greater than or equal to... What's the lowest y value that exists for this purple graph? The lowest point. Negative 4. Right? So that ends up being the minimum value of that graph. All right, let's cruise through this one. So All right. You know what I'm going to do? I'm going to graph the parent function, which you guys are now experts at. Where's my cursor? It's somewhere over here. What sort of transformation is going to happen in this one? What do you guys think? Yeah, the -3 is on the inside, so it's going to be a horizontal transformation. But careful. That's always sneaky. And because this is adding or subtracting to it, it's a translation, it's a shift. But which way? Yeah, it's the opposite for horizontals. So instead of shifting towards the negative x-axis, it's actually going to shift to the positive side, right? Everything's going to shift to the right 3 units is what's going to happen. Right? Oh, wow. I really like these arrows. Guys, I think these are some of the best arrows I've ever drawn. I'm quite proud of myself. So it's a horizontal shift right 3. And so let's connect the dots. Fa la la la. And the vertex got shifted over to the right. Right? So your guys, how did you guys feel about these problems last night? I mean, they're a little... Yeah? Okay. Because I didn't know how good of... I said a whole bunch of stuff yesterday, but I didn't know if I said too much stuff that it just... I was hoping that it would kind of connect for you. So there's that. Horizontal shift. Let's see. Now this is being multiplied on the outside. What's that going to do? It's actually got 2 things that happens to it. What are your guys' thoughts? What's gonna happen to the graph? So here's the parent function. It starts with a vertex at the origin, up 1 over 1, up 1 over 1. It's going to be a vertical stretch by 5, and then the minus sign, that piece of it, oh, well, it was better when I did that, tells us that it will be flipped. Flipped over the x-axis, which you could think about as being like a vertical flip. So it's going to be flipped and stretched. So using these points, 0 is the height of this point. Multiply 0 by -5, you still get 0. Here's this point. This is at 1. What do I get when I multiply 1 by -5? 1 times -5 is -5. And how about 2? And why am I comparing these to their y coordinates? Why am I looking at y coordinates instead of x? Because it's vertical. Man. All right. Excellent. And so 2 multiplied by -5 is going to be all the way down at -10. Here, this one would have been mapped down here. And actually, because this is a mirror image, I could even just say, oh, it's going to be reflected over to this. And you could find it that way as well. So, did this change the shape of my graph? Yeah, it did. It done changed the steepness of my graph. So, this is now upside down. It's a vertical stretch. And today we're actually going to talk about the slopes of this a little bit more. The slope of the first one was up 1 over 1, right? What's the slope of this one here? This is going down how much? Yeah, that's going down 5 over 1. And over here is going down 5 backwards 1, so the slope here would have been up 5 over 1, right, if you want to think about it like that. So, and that's what we'll realize today, and I think I mentioned it yesterday, is that this slope of your absolute value graph is often going to be what your vertical stretch is, unless I start throwing in like horizontal stretches or smooshes. But your slopes are going to be related to this number. It'll be kind of like the plus or minus version of that number. Let's see, I think for sake of time, because it's a half day, I'm gonna leave it at that. Thanks for watching, friends. Bye-bye.